Dear students, welcome to the session. In this session, we just discuss the drawback in the array implementation of the queue. In previous video, we have discussed the implementation of the queue by using array as a storage. So if we are using the array as a storage, what is the drawback? So in some situation, the queue will not allow us to insert a new element even though the sufficient free memory is available. This is not the case in case of a stack implementation using array, but in the queue implementation using array as a storage, since the algorithm is designed like this, we are having this drawback. You consider this situation like initially what the queue is an empty. As per our algorithm, queue is an empty, and then what, that front and rear both pointing to what, -1. When we are going to insert a new element, that is what, nq of what, 5. So that r will be moved to that 0 as per our algorithm, that is what, 5 0 1 and 2, both the front and rear both pointing to what, the 0th location. 5 will be in this location. So again what, after inserting another element nq of 10 means, we are going to what, insert one more element, that is what, 5 10 and then 0 1 and 2, front no change, and then what, rear pointing to the recently inserted element. Again you are going to insert one more element, that is what, nq of 15. So this time what, this 5 and 10 and 15 will be there, and then 0 1 and 2, here front pointing to this one, and then what, rear pointing to what, this one. So at this situation, if you want to insert one more element, nq of 20, since that algorithm, whether the queue is full or not, in that we are checking only the rear reached the size -1, and then what, it meant that we cannot what, insert that element like this. So similarly what, here the rear reached the size -1, during the insertion of what, the 20, it will say that what, queue overflow. So we cannot what, insert that element, so it will say that queue overflow. So that the queue status will be what, will be the same, 5 10 and then what, 15 0 and 1 and 2, front and then what, rear. So now if you are deleting some element, that is what, a dq, like that, what you have called the dq operation. So dq operation, what it means, that the 5 will get what, deleted. So after deleting that element, so the 10 and what, 15 alone will be there, 0 and 1, the front pointing to this one, rear pointing to what, this one. See that content. So the maximum size of that queue is a 3 elements I can what, store now, but physically what, logically the queue containing only the 2 elements, because we inserted the 3 element and we deleted one element, the 5 is deleted, so that what, one free memory location is still is there. So logically the queue containing only what, the 2 elements. So the problem is, as per our algorithm, if you try to what, insert one more element, since what, the size of the queue is a 3, we can what, insert a new element. So we are trying to what, insert another element, that is a nq of 20 again. See that picture here, the free location is there in that front side. Since we deleted that element, it is what, freed. But what, since our algorithm, the nq algorithm, look at that nq algorithm, we are checking is queue full. So is queue full means what, that will check only that rear reached the size -1, we come to the conclusion that what, thereafter we cannot what, reach. It means that in is queue full, we are not checking the free space available in the front side or not. So this is the standard algorithm. In that algorithm we are not checking that. So what is the problem here is, it will check that rear, since the rear reached that, this is 0 and 1 and then what, this is 2. Okay, this is 0 and 1, 2. Since the rear reached that size minus 1, size minus 1 is what, the 2. Since we reached this one, it will say that Q what, overflow. So it means that we cannot what, insert, like that it will send the message Q overflow. So this is the situation. In some situation, what in this, like in this situation, even the memory free space available in the front side, as per our algorithm, okay, Q algorithm, okay, there, since the rear reached the size minus 1, it is saying that we cannot insert that element. So logically, if you look this situation, it is a wrong one. So we have the space because the size of the Q is fixed as a 3. Okay, the Q physically now it is containing, logically it is containing what, only 2 elements, and 10 and what, 15. But as per our algorithm, logically what, the Q will not allow you to insert that element. So if you want to insert that element means what? So entirely the 2 elements, again the 2 elements should completely get destroyed. Then only what, the Q will become an empty. So I need to call the DQ operation again 2 times. So that 10 will get deleted and then 15 get deleted. By the time front and rear will move to what? The minus 1. So when the Q completely get what, empty, then only you can what, insert that element thereafter. So once we reached that the Q overflow status, okay, so thereafter what, you are allowed to insert an element only if the Q is completely what, empty. Till that it will say only the Q what, overflow. So this is one drawback is there in what, implementation of the Q by using only that array. But when you go for that implementation of the Q by using the list, this kind of things will not be there. This kind of the drawbacks will not be what, there. So but here, how to overcome this drawback in that implementation of Q using that array. So what is the solution for this situation? Okay, we need to modify that algorithm. Okay, we need to modify that algorithm by designing the Q as a circular Q. Okay, circular Q. So this is the solution for this problem. It means that there are 2 solutions to that. That is what, one is what, you can go with what, implementation of Q using the list as a storage. If you want to implement the Q using an array, and if you don't want this kind of what, issues, then you should design the Q as what, the circular Q. What is a circular Q means what? Logically what, physically it is an array only. So that Q is an array. Logically we have to what, connect the front and then what, the rear. It means that we need to look that array as a circular way. For example, array with that 3 elements will be what, viewed like this. Okay, so this is the index 0, this is the index 1 and this is the index 2. It means that when we reached that, that is the rear reached, this is what, 10 and then what, this is 15. Okay, this is F pointing to that 1, okay, and the rear pointing to what, the 2. So since our algorithm what it is doing, the rear reaches the size minus 1, it is saying this Q overflow. But in the circular Q, it should not say immediately if what, the rear reaches the what, size minus 1. It need to check what, the space is available in the front side also. That means the 0th location is the free or not. Like that also what we have to check. If it is a free means what, the rear need to be moved to the 0, not to the 3. Instead what, it need to be moved what, 0. So the rear and the front always what, will be rotated in the circular way. So the front value 0, 1, 2, then it will be moved to the 0, again 0, 1, 2. So when we are incrementing the rear, again what, it need to be moved 0, 1, 2, 3 like this. So in this circular way we have to what, design. So for that all these algorithms needs to be what, changed. Okay, so this design of the circular queue, you try yourself by referring the net, okay, by modifying the existing algorithm. Okay, first you implement the linear queue. Linear queue means what we have discussed in the last video. Okay, so using that array, so just what understand the linear queue concept. Okay, once you understand that concept thoroughly, you try to understand that situation, that is what the drawback in that queue. Okay, then you overcome the drawback by modifying that program, by designing the queue as a circular queue. So in this way, what you do yourself, what design the circular queue yourself by design, by referring what the net. If you need help, any help, I will give you. Okay, so if you have any doubt in this drawback, you can ask me. Okay, thank you.